So in the previous video, we introduced the rules for determining if if a number in a measurement is significant or not. And that doesn't mean, significance doesn't mean if you're dating or not. I thought that was funny. When talking about significant figures, significant means does it speak to the level of precision of the measurement? And there were rules to determine if a number was significant or not. And so we're going to use those rules, we're going to practice those rules with these examples to determine how many significant figures are in that particular measurement. So for the first number, I see I have two non-zero numbers, so those are automatically significant. I have a zero in between those two non-zero numbers, so that zero will be significant. Then I have these guys. Those zeros are considered trailing zeros because they are to the left of the first non-zero number. And those are examples of zeros that are not significant. So this first number in selection A, that number has a total of 3 significant figures. The 5, the interior 0, and 3. Those are all significant. These other zeros are not significant. Choice B, 5,300. Well, we have our non-zeros, so those are definitely significant. I have those two zeros and no decimal point. So those zeros would fall under the trailing ambiguous zeros. So those zeros, since they are by an implied decimal point, are ambiguous, so they are not significant. So that number, 5,300, has a total of 2 significant figures, with these zeros not being significant. Now, if there was a decimal point there, then they would be zeros that are significant. Selection C, I've got 3 non-zero numbers, and then I have 3 zeros that fall to the right of the decimal place. Zeros that are to the right of the decimal place are significant. So in choice C, all of these digits, all of these numbers are significant. So this measurement has a total of 6 significant figures. All of them would be significant. And hopefully you can see by the rules we've talked about here, 503 would have a total of 3. All of them are significant. E would have a total of 4. The zeros in both of those cases are interior zeros, and so they are significant. Letter F, 10,000. Got the 1, that's a non-zero, so that's definitely significant. And then I have these zeros and no decimal point. So then, since there's no decimal point, those zeros fall under the ambiguous rule, so they are not significant. So F, this number 10,000, would have a total of 1 significant figure. There were approximately 10,000 people, but if I knew there were exactly 10,000, now I've got zeros and a decimal point. I have zeros that are to the left and to the right of a decimal point, and that decimal point makes all the difference because that makes those zeros significant. So letter G would have a total of 5 significant figures. Looking at H, we have the non-zero 2. We have these 2 zeros that are trailing zeros after the decimal point. And then so the first 2 and then the last 2 zeros would be significant. The remaining zeros, those are the zeros that fall to the left of the first non-zero number. So they would not be significant. So letter H has a total of 3 significant figures, and I has a total of 4 significant figures. So There are other example problems on Canvas, on the Chapter 2 Canvas worksheet that you should take a look at. You should feel comfortable being able to use the rules for significant figures when given a measurement to say something about the precision of a measurement and be able to determine if a particular number in that measurement is significant or not. So in this exercise, we used those rules just in terms of an actual number. In the next video, we're going to talk about how to use rules for significant figures when we actually do something with numbers, meaning multiply, divide, add, and subtract.